Good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and here we are on to the topic Analysis of Variance. This is a design thinking approach on the problem of analysis of variance. Here we have an agricultural problem, and in which we deal with all stages of design thinking approach. Here we have a student to explain or say the 5 stages of design thinking. What are the 5 stages of design thinking, ma'am?
The 5 stages of design thinking are empathy, define, ideate, prototype and test.
So, empathy, define, ideate, prototype and testing. So, these are the 5 stages of design thinking. So, how we will implement these stages in our particular problem, we will look on to it. So, here is our problem. Here, our empathy is to analyze for the treatment effects. So this is an agricultural problem. Here we are given with some of the treatments to different yield for the crops. So these are the plot numbers. We have taken some 10 plot numbers in an agricultural land, and for that we are given some of the treatments here. Treatments means we are just filling out some of the fertilizers like so. So these are the treatments. The total treatments are A, B and C here. And also we are given with the yield. After the treatments, the yield of the particular plots are also given. So what we have to analyze here is analyze the treatment effects. How the effect of the treatments are happening for the particular plots are analyzed here. So this is our empathy problem. So this is our problem statement on the first stage of design thinking. What is our problem here? What is our problem? Agricultural problem. And what are we given with?
Plot number, treatment and age.
How many treatments are there?
3.
What are they?
A, B, C.
A, B and C. So for the particular plots for particular plot numbers 1 to 10, we are giving some of the treatments A, B and C, and this effectiveness is checked here or analyzed here. So in table 1, we are just defining the problem here. What we are about to define, we are just going to check for the treatments and the yields. How many treatments are there here, ma'am?
3.
3 treatments. What are they? Tables. So for which we are mentioning the yield numbers here in the table number 1. So actually we have defined the problem, which is our second stage of design thinking here. So defined accordingly to the treatments and the yields. What is our next stage? We have to formulate it. What type of formulation we can choose for this analysis is analysis of variance can be categorized into 3 methods, which is completely randomized design, randomized block design and latent square design. So for this particular problem, for this particular agriculture problem, we can take the completely randomized design concept, wherein we will be evaluating the treatments and the errors, or analyzing the treatments and the errors as explained in the table. We have already learned about the steps which are to be procedure to be followed in the completely randomized design. So for that, this can be explained with the help of a student. The steps have been explained earlier, and this will be explained by our student here.
So here we are taking the first column as x1, second column as x2 and third column as x3, and we are doing some minor calculations to find the summation of each.
Okay, so summation of x1 is found here, and its square values and its summation is found in the second column. Likewise, we have completed this table number 2. And what do we do in step number 3? We will be ideating the process. What do we ideate here? We will have all the formulae to compute the necessary requirements for the prototyping here. So what are the needies here? First one is
N equal to 10.
N is total number of observations, which is 10. Second one is
C is equal to 3.
C is the number of columns here. How many number of columns we have? 3, and that is what we have mentioned it as 3. And what is T here? Next thing is T.
The sum of all the summations.
Sum of all the observations here. So how many observations are here? Here we have three columns of observation, and all of the summation are put together under this formula T. And the next one is here, which is the correction factor. Correction factor formula is T squared by N, which is also an ideating process. And on computing it, we will have it as 160. And the next one is sum of the squares of the treatments. Here we have another student to give the explanation of the ideation process. The next thing is SST. What is SST here? be the formula?
And adding all solutions for
Okay. We are just adding up all the squares of the summations here, so that, and we are just reducing it with the correction factor also. Correction factor is a major important thing, which is the error occurring in the process. So on reducing it, we will have the value of SSC to be 40. And the next value is to calculate SSC. What is SSC? Sum of the squares of the columns. Columns are nothing but the treatments here. So on this is the formula to find the value of SSC, and on the correction factor is also reduced here. So the value of SSC is, next one is, what is MSC? SSC by C minus 1. What is MSC? MSC is nothing but the mean sum of the columns. And what is SSE? SSE is nothing but sum of the squares of the errors. So we have a formula here. This is also coming under the ideation process only. And the next one we will be calculating MSE is nothing but SSE by N minus C. So its value is 4.86. These can be calculated with the help of a simple calculator. So this is the ideation process wherein we have found all the requirements for the prototyping thing. Here we have a student to explain the prototype process of this particular problem.
So in the prototype we have ANOVA table. This table is very important to solve this problem. In here that we have source of variation, degree of freedom, sum of square, mean sum of square, variance ratio and treatment value. Table value. So in source of variation we have treatment and error. After the degree of freedom we want to minus column minus 1. That is 2, and between errors n minus e. We have already found n, and we know the c, that is 7, and we have already found that sum of squares.
In the ideation process we have already found SSC and SSE. So that particular value we have just put that here. Next one is,
In ideation process we have already found MSC and MSE. After that we want to find F calculator, that is MSE by MSE.
so how we will calculate F calculator? The bigger value will be on the numerator and smaller value will be on the denominator. So this is why we have put MSC on the numerator and MSC on the denominator.
So after that we want to calculate F tabulated. That depends on this, which value comes in the numerator, that will be the first step. This is degree of freedom of errors and degree of freedom of treatment. That value is 19.35.
19.35 can be calculated from the table for degrees of freedom 7, 2 in the F distribution table. So this is the prototyping process of this particular problem. Thank you. So after completing the prototyping process of this particular problem, we will be moving on to testing, which is nothing but the sources. From the given sources, we are just going to test the process here. What we have to test, what we are asked to test, we are asked to test for the treatment effects. So now we have tested for treatment effects with the errors happened, and finally we have just calculated with the help of F test. This F calculated value is 1.62 and F tabulated value is 19.35. So in this, on comparing it, we have got that F calculated is lesser to the tabulated value. Therefore, we will be accepting the H0 as per the completely randomized design procedure. So what is our H0? H0 is nothing but the null hypothesis. Null hypothesis is no difference. No difference means if we are applying these particular treatments also, the effect remains the same for all the plots. That will be our conclusion. Therefore, what will we conclude, or after analyzing what we have got here, is the three treatments are not significantly different. They are not significantly different for the productive yields. So this is how we implement the design thinking approach on this particular analysis of variance problem, and we will see later videos on the next video as well. Thank you.